Have you ever wondered how ships, planes, or even your GPS know exactly where to go on Earth? How explorers once navigated vast oceans without ever seeing land? The secret lies in a grid of invisible lines encircling our planet, the lines of latitude and longitude. These lines form a coordinate system that allows us to pinpoint any location on Earth, turning a massive, seemingly endless globe into an organized, understandable space. Latitude lines, also called parallels, run horizontally around the Earth. They measure how far north or south a location is from the equator, which sits at 0 degrees latitude. The equator is the widest latitude circle and divides the planet into northern and southern hemispheres. As you move toward the poles, these lines become smaller, eventually shrinking to a single point at the north and south poles. Latitude tells us much more than just position. It explains climate patterns, sunlight exposure, and even how seasons change. Cities near the equator, like Singapore or Quito, enjoy warm, fairly consistent temperatures year-round, while high-latitude cities like Reykjavik in Iceland experience long, dark winters and endless summer days. Latitude lines also reveal Earth's incredible ecological diversity. Between 0 degree and 30 degree north and south, you find tropical rainforests, savannas, and deserts. From 30 degree to 60 degree, temperate forests and grasslands dominate. Beyond 60 degrees, tundra and polar ice become the norm. Longitude lines, also called meridians, run vertically from the North Pole to the South Pole. Unlike latitude, longitude measures how far east or west a location is from the prime meridian, which sits at 0 graden longitude in Greenwich, England. Together with the 180-degree meridian, the prime meridian divides Earth into the eastern and western hemispheres. Longitude is crucial for timekeeping. Because Earth rotates 360 degrees in 24 hours, every 15 degrees of longitude represents a 1-hour difference in time. This system allowed sailors and explorers, like those in the 18th century, to calculate local time and determine their position at sea, a breakthrough that made ocean navigation far safer and more precise. Combine latitude and longitude, and you get a global coordinate system capable of pinpointing any place on Earth with incredible accuracy. For instance, the Eiffel Tower in Paris sits roughly at 48.8584 degree N latitude and 2.29435 degree E longitude. The Great Barrier Reef off Australia's northeast coast stretches between approximately 10 degrees S and 24 degrees S latitude and 142 degrees E to 154 degrees E longitude. Even Mount Everest can be precisely located at 27.981 degrees N latitude and 86.9250 degrees E longitude. GPS systems now use these coordinates to guide cars, planes, drones, and even smartphones, all based on principles developed centuries ago from these simple, invisible lines. Latitude and longitude also help explain weather, ocean currents, and biodiversity. Tropical regions near the equator experience direct sunlight, leading to warm temperatures and high rainfall that sustain rainforests. Polar regions near 90 degrees north or south latitude are cold and icy because sunlight hits at a low angle. Longitude influences not just time, but global communication, trade, and international coordination. News networks, airlines, and shipping companies all rely on precise longitude to schedule events across multiple time zones. Culturally, latitude and longitude have shaped human settlement and exploration. The Silk Road, which connected China with Europe, followed latitudinal corridors that provided predictable climates for agriculture. The transatlantic voyages of explorers like Christopher Columbus or Ferdinand Magellan depended on understanding longitude and latitude to navigate the vast oceans. Today, the same concepts allow global mapping of everything from climate change patterns to migration routes of animals like whales and birds. Fun facts make latitude and longitude even more fascinating. The Tropic of Cancer, approximately 23.5 degrees N, and Tropic of Capricorn, approximately 23.5 degrees S, mark the furthest points where the sun can appear directly overhead at noon. The Arctic Circle and Antarctic Circle mark the latitudes beyond which there are at least one day of total darkness and one day of total sunlight each year. These invisible lines tell us about extreme phenomena like the midnight sun, polar nights, and the changing length of daylight phenomena experienced differently depending on your hemisphere and latitude. Longitude, on the other hand, helped solve the famous longitude problem that plagued early sailors, and even inspired the invention of highly accurate marine chronometers in the 18th century. Understanding latitude and longitude is not just a tool for geographers and navigators. It helps us grasp how interconnected the Earth is, why climate varies from one region to another, why human civilizations developed in specific areas, and even how modern technology like GPS, satellite imaging, and mapping apps work. These lines provide the foundation for understanding our world spatially, connecting the past, present, and future of human exploration. Next time you look at a map, open a navigation app, or watch a documentary on world exploration, remember that every point on Earth, from the peaks of the Himalayas to the depths of the Mariana Trench, exists within this invisible grid. Latitude and longitude are more than numbers. They are the framework of our planet, linking continents, oceans, climates, and cultures into a coherent story of life on Earth. Learning latitude and longitude sparks curiosity. It teaches students, travelers, and lifelong learners to think spatially, understand global systems, and appreciate the amazing variety and connectivity of the world around them. These invisible lines reveal how geography shapes every part of our lives, making the planet less mysterious and far more exciting to explore.